Hi, everyone. Welcome. We're going to give it a couple minutes and let some folks join, and then we will get started. Seeing Chris on the call. Hi, Chris Turner. How are you today? All right. Well, as people are trickling in, I'll go ahead and get started and get this kicked off. My name is Jenny Norris, and I'm the Membership and Program Senior Coordinator here at Elevate. If this is your first time joining, welcome. If you're a returner, welcome back. If you're not familiar with Elevate, we are an independent customer-led user group for Dell Technologies customers on that multi-cloud journey. We bring customers, partners, and employees together to share best practices, network with industry experts. And we do this by hosting virtual programs like today and our in-person events. In today's session, this is a little bit different than what we typically do. We have Kenny Lowe, special guest. He is the Director of Multi-Cloud Evangelism, Microsoft Regional Director, and MVP at Dell Technologies, and he will be doing a demo of Microsoft Azure AI. We're really excited to see this. If you have any specific questions, please use the Q&A function and the chat box as we typically do. Bill Leslie is also on the call today. He will be helping field some of those questions, and he may be pitching some of those questions to Kenny at the end. Bill is the Director of Cloud Platform Technologies at Dell Technologies. And before we get started, lastly, I just want to thank our sponsors for today, Dell Technologies, Intel, and Microsoft. And with that, Kenny, I will turn it over to you.
Awesome. Thank you so much. I'm excited. This, I think, is going to be a lot of fun. I will just get my screen shared there and we are good to go. Okay, so Jenny and Anne and Alison and team reached out a little bit ago and said, hey, Kenny, could you do a session about Azure AI on the APEX Cloud Platform for Microsoft Azure? And I said, absolutely, I can. And then they said, could you just make it all demos? And I went, okay, let's have a look at that. I spent some time building demos, looking through them, seeing what I could do. And I think the key takeaway I wanted from the session is that I wanted to build something and show something tangible and actionable. So many demos that we see are pie in the sky or for a huge enterprise or for use cases that aren't applicable to people. And I wanted to build something that everyone here can see value in and potentially go and play with themselves. So that's my goal. Let's see if we can succeed there. Step one, in order to talk about Azure AI services on APEX Cloud Platform for Microsoft Azure, is to look at Azure AI services all up and in general. And there are a lot of AI services available in Azure. They have their own dedicated infrastructure for this. They have cutting edge models built around ChatGPT and other models there. As well. They have their own Microsoft Turing models. They have an Azure Machine Learning Studio, which we can run on premises, by the way. So the Azure Machine Learning can be delivered on premises as Azure Arc-enabled machine learning. And they have Azure AI Studio for building large-scale and complex AI models and solutions as well. We're not going to talk about any of that today. What we're going to talk about is Azure AI Services. In a previous life, these were called Azure Cognitive Services. They got rebranded to AI because, well, everything needs to be AI. So these are basically pre-trained turnkey solutions that you can use to build your own applications from. They're not applications in their own right. They are API endpoints, effectively, that you can pass data into and get an output out of. So things like Azure AI Document Intelligence and the language service and translation and vision and things like that. So step one in our journey here is to have a look at how you would utilize the Azure AI services running inside Microsoft Azure. So we start off in the Azure portal here, portal.azure.com. This is going to be our home for the entirety of this session here today. I'm not going to do anything. Well, we'll use some PowerShell, we'll use some Visual Studio Code, but predominantly in the Azure portal here. And in order to deploy an Azure AI service, the first thing that we need to do is go to Azure AI Services. And you'll see down the left-hand side, there are a whole bunch of different services available for you to take advantage of here, things that we've already mentioned, like computer vision, the face API, and speech and language, and so on. And it's the language service here that we're going to focus in on today and do some demos and learn a bit about here. In order to deploy this language service, you have to click into the language service there, click create, and then from there you can just create that language service API. It's extremely straightforward. Now I'm going to be doing things mostly in the Azure portal here. You could use ARM or Terraform or Bicep or PowerShell or Azure CLI or whatever your deployment mechanism of choice is. For a demo, it's sometimes nice to see the portal here anyway. So you choose your resource group to deploy into, you select which Azure region you want to deploy this service into. For example, East US, this is the Microsoft data center that this service is going to then live within. You name it, you choose a pricing tier. Do you want the free tier, which allows 5,000 operations a month, or the S tier, which allows you 1,000 calls per minute, but is chargeable? That is your choice there. You accept the responsible AI notice, you create that, and you have an Azure AI service. Now, there are a few steps that I'm going to go through here that can take a minute to 10 minutes to accomplish or to finish. So I've got a few things pre-deployed here, but I am going to show every single step here that we need to go through in order to use any of these services. I'm going to try and not skip anything so that you can see every part of the sausage within this. After you've created that language resource there, basically what it gives you is an API endpoint. So I've got this API endpoint now, elevate-language.cognitiveservices.azure.com, and it gives me a key that I can authenticate against in order to use that. The API kind here is text analytics. What can I do with it? Well, that's easy. We can click on the Discover tab here, and it tells us the different things that we can do with this AI service. We can extract information, classify text, understand conversational language, and so on and so forth there. Let's look in the first one there, extract information. So we can basically pass existing text or data into this API and have it perform personally identifiable information extraction or extracting key phrases, finding linked entities within data, a whole bunch of different things here. Big fan of the analyzed health related data there, a service just for analyzing health data specifically. We're going to look at the first one here, because it's the first one, so why wouldn't we just look at the first one here? But also I do have a use case for this, which I wanted to do in a previous life in a role many years ago and I wasn't able to do. And now I think that whereas I would have needed a large team, a lot of money, and probably years to accomplish this in the past, I reckon I could knock up that use case in about an afternoon as an MVP now. And that's one of the things I want to chat about in a bit. The personally identifiable information API here basically uses NER to identify sensitive personally identifiable information and then categorize that and optionally remove that from data as well. So I think hopefully we can see a lot of use cases for this already if you have a lot of existing data. We can click into the Learn More button here to learn more about how to use this. If I scroll down, it gives us our typical workflow here. Create the Azure AI language resource. Tick, we have done that. Step 2, create a request using the REST API. We've not done that yet, but we absolutely can. Send the request to that REST API and then store the response locally. These are all the things that we are going to do within here. Now, in order to create a request using the REST API, I need to understand how that REST API works. If I scroll down a little bit, it's going to tell me what different types of data I can send to the API. The most common ones you'd expect, text, PDF, docx, and so on there. That is good to know. Scroll down a little bit and we get the REST API documentation there. So that's what we need to be able to build an application around this. Click through to the Analyze Text API, and immediately we get the post endpoint that we need to be able to send data to that endpoint there. We already know what the endpoint is. That is our, scroll to the top, elevate-language.cognitiveservices.azure.com there. That's our endpoint. This is the format that we need to put stuff to that endpoint there. If I scroll down a little bit further, it's going to give me the format that I need to send that JSON request as. So this is all I need to know to be able to start to build an application targeting that API endpoint there, that language text analysis API endpoint there. So this tells me the format that my JSON needs to be in, what I need to send. From there, I can build a simple application. So let's do that. If I open up Visual Studio Code here, I've created a very simple text document here with some personally identifiable information. John Smith lives here. This is his email address. This is his credit card number. I want to be able to pass this data to that API and get a redacted result back. I want to be able to have this, this document here, but without PII within it. Now, obviously, this is just 3 lines of text here, but imagine if you have hundreds, thousands, tens of thousands of documents dating back tens or sometimes hundreds of years that you're needing to work with and digitize and be cognizant of what PII you're storing within that. This is a very real use case that I had when I worked at a newspaper and magazine publishing company, 100 and something year old newspaper and magazine publishing company, where we wanted to digitize and store huge amounts of data that we had in from readers and from articles that we'd written and all sorts there. But data protection laws meant that we couldn't necessarily keep some of that more recently created stuff for over 7 years. Older stuff was fine. But to be able to digitize and store that effectively and appropriately, we would need to redact a whole bunch of PII data, but it just wasn't feasible given the enormous amount of data that we had within the organization. There are literally over 100 years of newspapers, magazines, daily publications, ridiculous amounts of data there. It wasn't feasible at all there. If I want to pass this text to an API endpoint, I can do that with PowerShell. I can do it with C#, I can do it with Python, whatever, it doesn't matter. I'm going to use PowerShell because I like PowerShell. So I define the AI service URL here. So that is that URL that we saw me create within Azure earlier. That is the API format that we saw in the API documentation that we need to pass that to. And the rest of this is just generating that JSON that I'm going to post to that API endpoint. So I'm not going to show you my API key because then you'll all go and spend my money, but that's just one line within there that is the API key. Everything else is just setting the content headers, reading in the data from that sample text file here. So just get content PII sample.txt, escape anything within that needs to be escaped, and then define the JSON body here as was in that documentation that we looked at earlier. So the kind that we're looking at here is PII entity recognition. There are lots of different types of PII that you can look at within here. You can look at social security numbers and tax IDs and all sorts of things across lots of different countries and things as well. I'm just looking at person, credit card, phone, email, and address within here, because those are some of the things that I've got within that text file that I've got there. And then this was the format to actually send that text there as well. And all I'm doing is sending that PII text escaped, which is the data read in from that text file. And then I will post that using invoke REST method to that URI with those headers in that JSON body, read the response and put it in another text file. That's all this is. So that's how quickly and easily you can build something which is going to run against one of these APIs. So good job, demo done, guys. Okay, I suppose I should actually try and run it as well. So if I jump into PowerShell here, then you see that I am within the folder there that has that PII redact.ps1 file, which we were just looking at there. So if I run PII redact.ps1, then this is going to post that data from that text file to that API endpoint. And if I go back into Visual Studio Code, it's created a new text file there, which is a redacted text file. So all PII has been removed from that. Obviously, it doesn't leave this very useful here in this file here, but if you have lots of documents where only a small subset of that data is PII, and there's lots of other useful information in there that you need to keep, as is typically the case, this is enormously useful for you to be able to do within there. So that is how you can use an Azure AI service to redact personally identifiable information very easily. But there is a problem, and the problem is manifold. The problem is that lots of enterprises in particular, but lots of companies and lots of use cases aren't able to make use of these services, specifically when they run within a Microsoft data center. This could be because they have too much data to shift there. It is a data gravity problem. So there's too much data physically to put into the Microsoft data center to be able to do that. You could have data security and privacy concerns. This is, I think, a very real one around personally identifiable information. You have this stored on premises, but can you put this to the cloud in order to even use that service to redact that PII data because you've had it there living in the cloud in the first place there? Or do you just not have enough bandwidth to be able to constantly stream lots of data? If you only have a few documents, not a big concern. If you're talking about 100 years of hundreds of thousands, if not millions of documents streaming through and other things being generated all the time as well, low bandwidth or intermittent connectivity can be a real barrier to this as well. Good news is that Microsoft recognized that this is a problem and have created a suite of capabilities to be able to bring some Azure services on premises. They do this predominantly through what they call Azure Arc. Now, Azure Arc is not one thing, it's a suite of capabilities that allow you to A, project on-premises resources into Azure to bring some management capabilities there. That's not what we're talking about here. The other thing that Azure Arc helps you do is to take services which have historically been locked within the four walls of a Microsoft data center and bring them down on premises. Typically, this is done on top of a Kubernetes environment here. Now, Azure Arc is able to do that across any environment. This is not just locked within the Microsoft ecosystem here. If you have a Tanzu environment or EKS or GKE, or you've got Kubernetes running on top of Nutanix or any of these, then you can use Azure Arc enabled services to bring some services down onto those. The key is that the value that Arc brings stops at that workload. It doesn't extend on down into the infrastructure as well. But if you have existing infrastructure and you want to rub a little Azure onto it, you can do that with Azure Arc. If you are looking at net new infrastructure or looking at migrating workloads and looking at what is the best Azure integrated system here and Azure integrated experience, that is what Azure Stack HCI is here to do. It's here to take that Azure Arc experience, extend it to the workload, to the software-defined infrastructure, through to the physical infrastructure, and give you one unified way to deploy, manage, license, and support everything from disk to cloud and everything in between. That is the point of Azure Stack HCI. So it's not the only solution that will enable this, but is the best integrated solution, and that's why we're focusing on it today. If we look at Azure Stack HCI, the best way to deploy that, and the most tested, most rigorously tested, quantifiably so, is the Dell APEX Cloud Platform for Microsoft Azure, in which we have designed and built a whole new testing regime with Microsoft, which has been unique to Dell, to make sure that everything through the entire stack is being tested for every release in this solution here. But that's not the point of this session. For more information, look back at the recordings of a previous session I did about that on this community hour. On top of the physical infrastructure there, you have the Azure Stack HCI operating system, which gives you Hyper-V and Storage Spaces Direct, and optionally today, software-defined networking as well. And on top of that, you can run some, let's call them traditional or heritage type workloads there, Windows or Linux virtual machines, or even Azure Virtual Desktop now, one of those things which you can manage from the Azure cloud and deploy on premises there, getting the benefit of AVD, but on your terms, on your premises there. We're not here to talk about that either. What we're here to talk about is Azure Kubernetes Service enabled by Azure Arc running inside Azure Stack HCI, and then on top of that, running Azure AI services like the ones that we just saw there, running that text analytics service there. All of this is then wrapped up in a warm, cozy blanket by other Azure services, which allow you to use things like Monitor, Policy, Insights, Defender, and a whole bunch more to just enhance the on-premises experience here, wrapping the best of Azure onto that while giving it to you in your data center where you need to run your specific workloads. So this is our focus for our next set of demos, the Azure Kubernetes service enabled by Azure Arc, and then Azure AI services there. And there are a whole bunch of Azure AI containers that we can run on top of here. There is I'll try and put the link in the chat in a little bit, but through language, translation, speech, document intelligence, vision, and a bunch more there as well. There are lots of these that run in Azure that you can run and get the exact same experience on premises, actually sometimes faster on premises, depending on your hardware and your infrastructure there as well. So I forgot I was going to do demos now. That was my last slide. So how do we demo this? Oops. So step one, we need to look at a freshly deployed Azure Stack HCI cluster. I didn't want to go into this and say, here's something I've built everything out on, and here's the end result here. I wanted to start off from scratch. Assuming that you have just deployed your Azure Stack HCI cluster and done literally nothing with it. So that is what this cluster has been set up as. It has been freshly deployed. Nothing has been done to it at all. You'll see there are still updates available. No configuration is done. The reason I wanted to show this is because one of the first tasks you have when you deploy an Azure Stack HCI cluster, and I should note that I'm still managing this within portal.azure.com because even though this runs on premises and this is a hyper-converged infrastructure running on premises, this is still your management plane here. That is the point of Azure Stack HCI. Use Azure for managing everything through the entire stack here. The first task that you have to do is to create a logical network. And a logical network is just an Azure representation of an existing virtual network in your Azure Stack HCI system. When you deploy your Azure Stack HCI, it's going to have a virtual network, a virtual switch already created there called Converged Switch Compute Management. There may be more depending on how you set up your networking there, but basically you're just creating a logical representation of that within the Azure portal so that when you deploy things in Azure, it knows which virtual switch to target on premises. That's all this is. It's just linking to on premises. It's not actually changing or setting anything on premises. It's literally just an Azure object representing your on premises logical network. So once you have created that Azure logical network, jump to another cluster here, then you will have that represented here within your logical network. That is the only thing that you need to do to be able to start deploying Kubernetes clusters. That is the one prerequisite before you can deploy a Kubernetes cluster, which maybe it's a bit too onerous, maybe other things make it easier. I don't think so. I think that's one of the easiest ways to get going with Kubernetes here. In order to deploy a Kubernetes cluster, then all I need to do is go to Kubernetes clusters and click create a Kubernetes cluster, or use infrastructure as code or Azure CLI or whatever. But here again, we'll go through it with the Azure portal just to give a GUI-driven experience here. And all we need to do is give this a name. I don't know what names I've used, so let's just make one up. And now, whereas typically when deploying AKS, you would choose which Azure region you want to deploy into, UK South, West Europe, East US, and so on here. I get a custom location, which is the name of my Azure Stack HCI cluster. This is targeting an AKS deployment into my Azure Stack HCI environment here. I choose what Kubernetes version I want, and I will always go for the latest available there. I choose what size I want my primary node pool to be, so where my pods are going to run, the actual workloads there. What do I want the size of that to be? I can choose different VM SKUs here, including just CPU enabled, or there are GPU enabled options as well. So for example, anything with an A2 in it there is going to attach to an A2 or a partitioned A2 if you have those in. There are also A16 SKUs available, so you can use GPUs within AKS as well, either direct attached or partitioned there in multiple different ways. I will just use a normal standard VM here because I don't have any GPUs in this system. And then you can do 1 to 64 nodes within that, depending on what capacity you have and how big you want that node pool. Within a Kubernetes cluster, you can have multiple node pools as well, and you can have Linux or Windows node pools. So whether you want to run Linux or Windows containers, the choice is yours. If we ever need to log into those node pools, we need to have an SSH key, so we will create that. We choose the resiliency that we want for the control plane. Typically, if you roll your own Kubernetes environment, you need to think about a lot within that control plane. It is delivered effectively as a managed service for you within AKS, but you still want to choose the resiliency of that control plane and also the size of that, depending on how many operations you're going to be passing through that control plane as well. Again, I will go with the defaults here. I have the option to add additional node pools here if I want. Then I'm just choosing if I want to use Kubernetes RBAC or integrate with Entra ID for my RBAC there. I always go with local Kubernetes because I just like falling back to kubectl and working from there. This is the reason why I needed to create that logical network earlier. This is the only thing that we need to set here. So I need to choose that logical network there, give it an IP address, click create. That is the process for deploying a Kubernetes cluster out of the box from Azure Stack HCI. From that point, I can start deploying workloads into that Kubernetes cluster and start using it, which I think is pretty awesome. Well, not exactly. There's one other thing, because that'll allow you to use node port, for example, but there's no load balancing within that. You still need to deploy something like MetalLB or some other load balancing capability within that Kubernetes environment. So the process for doing that, and here again is a freshly deployed Kubernetes cluster here. The reason that I didn't just deploy that one is because it takes about 12 to 13 minutes for a Kubernetes cluster to deploy. I didn't think we'd all want to wait, so here's a freshly deployed one. But again, nothing else has been done to it. I just clicked deploy there and waited about 12, 13 minutes there for that. After you do that, you can go into networking, and then the process to install MetalLB and get load balancing capabilities is to click OK, and that was it. So again, we have to wait a couple minutes here for that to install, and I'll spare us that wait there, but that's the process for enabling MetalLB within your Azure Stack HCI cluster. Within this AKS cluster here, you'll see that I have a load balancer created. All I had to do then was give it an IP address range, and now when I deploy a Helm chart or so on against this AKS cluster and tell it to use the load balancer type, it's going to pull from this IP range here and have an externally accessible IP address there. So now I'm good to go. I'm good to start deploying things into this Kubernetes cluster here, which is pretty awesome. The first thing that I deployed in order to test this was a little Super Mario game, actually. The process that I used, the process that I used for actually deploying this Mario game here was I went into ChatGPT. Oh, and actually, by the way, if you want to look at GPTs that are available, there is one called Geo's GPT where you could just click in and say, can you explain Dell's APEX Cloud Platform for Microsoft Azure, built by Ben Mayer and our team? And it'll go and tell you all that good stuff based on content built by our team there. So easy way to get started with the APEX Cloud Platform for Microsoft Azure here as well. But actually, I just went into ChatGPT and said, can you create a Helm chart to deploy a Mario Brothers clone to Kubernetes, use load balancer, not node part, and just find a container in Docker Hub or whatever. Literally what I said. They gave me my Helm chart. I ran that, and we got our Super Mario Brothers game, which I wasn't going to play, but maybe I shouldn't play. But that's how easy it is to then get something deployed within that. But that's not the point. That's not why we're here. We're here to look at Azure AI services. Now, if we go back to our previous slide here, that was the prerequisite. The prerequisite is threefold. Number one, have the physical infrastructure. Number two, have the Azure Stack HCI software-defined infrastructure deployed on top of that. That is delivered very, very robustly and easily with the fastest time to value through the APEX Cloud Platform for Microsoft Azure. Then on top of that, you need to deploy an AKS cluster there. And I think we just showed how quickly you can do that out of the box on Azure Stack HCI. Literally in less than 30 minutes, you can have Kubernetes clusters deployed and operationalized and working within there. So now we need to look at how we deploy those Azure AI services. The good news is that Microsoft makes a lot of these different Azure AI services available as containers that you can run on premises as well, including the one that we just chose there. In fact, I think on this slide here, there is a list available. We're just going to open in the wrong window, but here we go, Azure AI containers. This is a list of all those different services. You can scroll down through them: language service, detect language, sentiment analysis, text, and you can click into these and find the link to the actual container in the Microsoft Container Registry to be able to pull and use that here. So I'm using the personal identifiable information detection one, which is the same one as Microsoft is deploying in Azure, because spoiler alert, they're deploying containers as well. So it's delivered as a PaaS capability here. So if I go back to Azure and look into this Elevate language here, this is delivered as a PaaS, but it's just a container or series of containers behind the scenes, depending on how I set the scalability here. So this endpoint is just a container with an API endpoint there, and I want to deploy that on premises. So all I need to do in order to do that is to create a little Helm chart to be able to deploy this. So my Helm chart is going to say I want to deploy a single replica for this, so one container. We'll start off small here and then see how we go. The repository it's going to pull this image from is the Microsoft Container Registry.microsoft.com Azure Cognitive Services Text Analytics /PII container here. So that's the image it's going to use the latest image, always pull when we deploy the Helm chart. Because we have a Metal LB set up, we can set that as a load balancer there. I'll use locally port 80. Due to the documentation, I know that the container internally runs on port 5000, so I'm just mapping port 80 to 5000, and that's effectively it. If I want to run this Helm chart now, then I just need to go back to my PowerShell and Helm install, oh, not help, although I do need help, Helm install PII, and pointed at that text analytics folder there where the Helm chart is contained. So the name of the deployment is PII. The folder there is where the Helm chart is contained. I hit enter and I continue talking because it's super important for me to fill the time while this is running, even though it's only going to take a few seconds. And then hopefully we're done. The PII deployment is done. That container has been pushed to my AKS on Azure Stack HCI environment there. And if I go back into my Azure Stack HCI system and my AKS cluster, and I look in the services and ingresses here, we should see that available. There we go, with the load balancer type there, with an IP address assigned by that Metal LB load balancer that we set up there. It has one instance just now, but if I click into that, it's going to do nothing because there is nothing running at this URL here. You need to post data to it. You can look at the Swagger definition. Swagger definition just tells you how to use the API here. So it's just going to tell us what we already know. If we want to analyze the text, then you need to post to this language / analyze text. This is the payload format here. So what is the process then? If I have an existing application which has been using Azure to do this, what is the process for me to change this to use my newly deployed Azure Stack HCI. First of all, I'm going to delete that redacted text file there. So it's gone, no longer exists. I'll go back into my PowerShell script here. I'll change that to HTTP. And I'm going to change the URL from being the one running in Azure to being 192.168.5. What was it, 202, I think. 202. So all things being equal, let's see if the demo gods love us. If I run that PII redact.ps1 again, it's doing the exact same thing. It's taking that text file, read it in, passed it to an API, but this time that API lives in a container running inside my Azure Stack HCI system here. And when I go back into Visual Studio Code, we see the same redacted text file and the exact same output because, spoiler alert, it's the same service, it's the same container, and you can use this to do the same outcome here within your Azure Stack HCI system, which I think is pretty incredible, actually. Now, if I go back into that PS1 file, there was another thing I wanted to touch on here, which is if I look at the JSON body of this, where are we? There's another thing that you need to define when you're pushing this through. So you send the text through that you want. So this is the text that I read in from that text file. You also need to define what language it's in, which can be a bit of a pain, especially if you have huge amounts of data there. Well, luckily, there's another container, there's another image which can do language detection. So why don't we just pass it through that container first, output the language files in, then pass the file with the language through as well. So you can start to chain these containers as well and start to build applications from this. So that was the demo there. I think that it's, well, I thought it's pretty cool. I really enjoyed building it there. It's very easy to get going. If I wanted to scale that, what does that look like? Let's go back into the Helm chart here and change the replica count to 3. From there, I can just Helm upgrade. There, it's going to read in that new deployment there and pass that to Kubernetes, and Kubernetes is going to say, all right, when I feel like it, I'm going to expand that from 1 container to 3 containers there. If we jump back into the portal there, then we can go to our workloads. Within the workloads, we should see that either trying to expand or it may already have done it. Let's find out. Yeah, so that text analytics service there has expanded 3 containers now. So behind that, there are 3 containers. That is load balanced by that metal LB load balancer that we created, and we can scale either the VMs that back that, the node pools that we created originally, or we can scale the containers within the node pools there, and we have very granular, straightforward, easy control of that using industry standard tooling here. There's nothing new that we had to use. Everything is just how you do it in Azure, literally how you would do it in Azure here, and I think that's one of the most powerful things that this service is enabling here as well. So that was my demo. I wanted to show really how to use Azure AI services on the APEX Cloud Platform for Microsoft Azure. Again, this will work on any Kubernetes environment or Docker environment that you have. What I really want the takeaway to be here is that there are lots of different layers to this solution here. There is the physical infrastructure through the virtual infrastructure, the software-defined infrastructure. There are VMs, and on top of the VMs, there is AKS, and on top of AKS, there are the Azure AI services. There is Azure Arc integration, and this is the only solution which actually pulls all that together as one unified, well-tested solution. You can go and do it anywhere else that you want, and I heartily encourage you to go and test this anywhere that you want. When you want to deploy into production, this is your most robust way of doing this within the Azure ecosystem here. With that, I think there are a bunch of things in the chat, and I wanted to save time for Q&A, and it looks like I've done that. So let's have a look at the chat. Jenny, Bill, is there anything I should be addressing straight off the bat, or are we in a good place?
You've got folks enthralled with your demo. I'm not seeing any questions, so now's the time for folks to put them in the chat window or the Q&A. We'll be watching there. Jenny, I think you had a couple things that you wanted folks to know about while people are putting their questions in for Kenny.
Yes. So a couple of things as you're putting your questions in. One thing, Microsoft Ignite is coming up in a couple weeks. Elevate will be at Microsoft Ignite this year. If you're attending, please go ahead and register for that. The link is in the chat. Registration is already getting full, so I encourage you to do that sooner rather than later. Another big thing is our annual member survey is now open. So please feel free to fill that out. Once you fill that out, you'll be entered in to win our sponsored gift package. We have a really nice package this year with a nice fire pit stove with a couple of other really cool sponsored gifts. Anybody else? Anybody have any questions?
No questions means it was either amazing or terrible. So I know which I'm going to pick.
It was incredible, Kenny. I was sitting here thinking, wow, Kenny, like we need you to do demos maybe every other month or something. And you did a good job. But with that, we'll go ahead and close it out. Thank you, Kenny. Thank you, Bill, for joining today. Thank you all for attending and hopping on. A couple of additional thank yous to our sponsors. Again, Dell Technologies, Microsoft, and Intel. Again, if you are attending Ignite, please go ahead and register for that event. If you're in the Chicago area but not able to attend Ignite, we would still love to have you. Our next community hour is on November the 7th. We'll open registration for that closer to the end of the week. It is going to be on Red Hat virtualization with Red Hat. So that'll be a very, very great conversation to see. And with that being said, if you enjoyed the program today and you enjoy being a member of Elevate, we encourage you to share future events with colleagues and for you to return to additional ones. And with that, again, thank you for joining, and we will see you at future events. Take care, everyone.
Thank you.
Bye, y'all.